This is the second video looking at electron shells, subshells, and how we represent atoms and electrons surrounding atoms. And on the screen I have put some of the rules that we're required to take into account when we try and place electrons around the nucleus of atoms. The first one is that we build up the atom from the inside out. In that respect, we fill the n equals 1 shell before we move on to the n equals 2, n equals 3, etc. The second important point is that we have to fill the whole of the shell and all of its subshells before we move on. The third important point is that when we start to fill a shell, we fill the shell with the lowest energy before we move on. In other words, we will fill the 2s shell before we fill the 2p shell. And the final point is that when we fill subshells, we fill them as single electrons before we move into doubling up the electrons. And the best way of looking at this is with some examples. So if we look at boron, boron has an atomic number of 5. That means it has 5 protons, which means in neutral atoms it's got 5 electrons. So let's consider how we place these 5 electrons. The first 2 electrons we place in the 1s subshell because this is closest to the nucleus. The next 2 electrons we place in the 2s subshell of the second shell because this is the next closest. And then finally the remaining electron we place in the first shell position of the p orbital. So we have 5 electrons distributed, 2 in the 1s shell, closest to the nucleus, lowest energy, 2 in the 2s subshell, second closest to the nucleus, second lowest in energy, and finally 1 electron in the first of the p orbitals, which is the next closest to the nucleus. And this can be summarized in a shorthand as 1s2, 2s2, 2p1. And as a check, if we add up the numbers 2, 2 and 1, we have 5 electrons, which corresponds to the 5 electrons of boron and matches the number of protons. Following the same rules with carbon, carbon has atomic number 6, therefore it has 6 protons and 6 electrons in its neutral atoms. We can see we place 2 in the 1s subshell, 2 in the 2s subshell, and we're left with 2 over. But in this case, look at how we draw them. We place 1 electron in the 1p dimension. We place the second electron in the second p dimension. We do not place 2 electrons in the same dimension. We only start doubling up when we have completely placed electrons, 1 in each of the dimensions for that subshell. And again we can write a shorthand, 1s2, 2s2, 2p2, and again 2 plus 2 plus 2 equals 6, which matches our 6 electrons. Following this through with nitrogen, nitrogen has atomic number 7, so it has 7 protons, 7 electrons. 1s subshell is full, the 2s subshell is full, and we have 3 electrons in the p subshell. 1 in the first dimension, one in the second dimension, and one in the third dimension. Again, no doubling up until we have single electrons in all of the dimensions. And moving on to oxygen. Oxygen has an atomic number of 8. So it has 8 electrons, 2 in the 1s subshell, 2 in the 2s subshell, and now we have 4 electrons to place in the 2p subshell. So we have 1, 2, 3 electrons, 1 in each of the 3 dimensions, x, y and z, and then the final electron we now start doubling up. So we place the 4th electron in the first dimension of the p subshell. And finally we come on to how we fill up the subshells, and there is an easy and neat way of doing this and working this out. It's by drawing up a grid similar to the one illustrated on the bottom of this page. If you can see what has been written down, we have all of the S subshells written underneath each other. So we have the 1s subshell, the 2s, 3s, 4s, 5s, 6s. And then we come on to the P subshells, 2p, 3p, 4p, 5p, 6p, 3d, 4d, 5d, 6d, 4f, 5f, 6f, 5g, 6g. And how do we fill them up? Well, the arrows tell us how we do the filling. We fill the 1s first, we fill the 2s second, we fill the 3s, the 2p, followed by the 3s. We fill the 3p, followed by, not the 3d, the 4s. So the 4s is filled in front of the 3d. So we fill 3p with 6 electrons. We then move on to fill the 4s subshell before we fill the 3d and the 4p. And if we remember back, the reason for that is because when we look at the energy of each of the shells, we see that the 4th shell, n equals 4, and the 3rd shell, n equals 3, overlap each other, such that the 4s subshell is at a lower energy than the 3d subshell. So the 4s subshell will fill in front of the 3d subshell. And that summarises how we fill electron shells. The way forward is for you to take on what's in this video, download the notes, read them through carefully, and then practice with relevant questions. Thank you.